morning. In last lecture we learned about circle, its terms and tangent, number of tangent. In this lecture, we learn theorem. Theorem is the tangent of at any point of circle is perpendicular to the radius through the point of contact. The tangent at any point of a circle. Here it is circle. Tangent of any point. Here we draw point P at the point of contact. We draw tangent. Suppose you draw here, then draw. Perpendicular to the radius through the point of contact. It is perpendicular. Perpendicular because that means it intersects at 90. Perpendicular to the radius of the point of contact. Tangent is perpendicular to the point of contact, perpendicular to the radius through the point of contact. First we draw figure with using compass, pencil and scale. Given. In theorem, we write three parts: given, to prove and prove. Given part. I draw here circle. A circle with center O. A circle with center O and a tangent xy to the point, to the circle at point P. Given part, a circle with center O and a tangent xy to the circle at point P. At the contact of point P. Point of contact P or point P. To prove, what is proof? Perpendicular to the radius. That means OP is perpendicular to OP is radius perpendicular to XY or XY perpendicular to OP. We have to prove OP is perpendicular to XY. Now proof. Take a point Q on XY other than P. Take point Q other than P. Here, anyway, except P. Take a point Q on XY. Take a point Q on XY other than P and join OQ. Here we write, suppose you draw here Q and then either way, here. Okay. And join OK. The point Q must lie outside the circle. Point Q must lie outside of circle. Outside the circle, not in circle, not on circle, but Q lie on outside of circle. Take a point PQ, take a point Q on XY other than P and join OQ. Q must lie outside of circle, outside the circle. If Q lies inside the circle, XY will become a secant. XY will become a secant. What is secant? A line intersect 2 points. The circle, it is called secant. A line segment whose both end points are lying on circle, then it is called chord. Here, second, that means this a line intersect the circle in 2 points, that it is called secant. Here, suppose P lies in, Q lies inside the circle. Q lies inside the circle. It becomes, xy becomes secant of this. Therefore, OQ is longer than radius. OQ is longer than radius. Here OQ. Radius is this, then it is longer than, Q is anywhere except P. It is longer than radius OP. Therefore, OQ is longer than the radius OP of the circle. That is, OQ is greater than OP. OQ is greater than OP. OQ, it is clearly we see that OQ is greater than OP. Since this happens for every point on the line XY except the point P. This happens every point of line XY except P. On except P, OP is less than OQ, any point, every point OQ, OR, OZ except P. OP is the shortest of all the distances of the point O to the point of XY. OP is the shortest distance of the point O to the point of XY. So OP is perpendicular to XY. That is OP perpendicular to XY. Again, this theorem. The tangent. What is theorem? The tangent at any point of a circle is perpendicular to the radius through the point of contact. First we draw figure, then write given and prove and last proof. Given point. O, a circle is with center O and XY is a tangent XY to the point, to the circle at point P. To the circle at point P. To prove OP perpendicular to XY or OP is perpendicular to XY. Proof. Take a point Q. Take a point Q on XY other than P. Other than P and join O. We write like this. Take a point Q on XY other than P and join O. The point Q must lie outside of the circle. Point Q must lie outside of the circle. If Q lies in the circle, then XY becomes secant, not a tangent. If Q lies inside the circle, XY will become a secant. Therefore, OQ is longer than OP, than the radius OP of the circle. OQ is longer than the radius OP of the circle, that is, OQ is greater than OP. OQ is greater than OP. Since this happens for every point on the line XY except P. This happens for every point on the line XY except the point P. OP is the shortest of all the distance All the distance OP is the shortest of all the distance of the point O to the point of xy. So OP is perpendicular to xy, that is OP perpendicular xy. Here hence prove this theorem. Write down, it is in your notebook. Now exercise 10.1. Question number 1. How many tangents can a circle have? How many tangents can a circle have? A circle have, here is tangent, here is also tangent, here is also tangent, here is also tangent. Then we draw. A circle can have infinitely many tangents. How many tangents? Infinitely many tangents. There are infinitely many points on circle. Circle having many points, infinite points, and each point have unique tangent, and each point of it has a unique tangent. Then question, how many tangents can a circle have? A circle have infinite many tangents. There are infinite many points on the circle, and each point of it has unique tangent. Question number 2. Fill in the blanks. Number 1. A tangent to a circle intersects it in dash point or points. This is tangent. It is intersect circle in how many points? Only one. It is tangent. Here is tangent. Then suppose it is a tangent. Then it is intersect circle at one point. How many points? One. A line intersecting a circle in 2 points is called, in theorem, I remember, I understand, learn you, a line intersecting 2 points, circle in 2 points, a line intersecting a circle in 2 points is called, in 1 point, a line intersecting 1 point is called tangent. 2 point is called secant. Number 3. A circle can have dash parallel tangents at the most. A circle can have, suppose it is a circle, can have dash parallel tangents. Parallel tangents is, how many tangents draw? 2 parallel. Suppose it is here. One tangent is here, then its parallel tangent is here. A circle can have 2 parallel tangents at the most. Not more than 2, only 2 parallel tangents. A circle can have 2 parallel tangents. Suppose this, then its parallel is this. The common point of tangent to a circle and the circle is called. It is our freedom. The common point of a tangent to a circle. Here is a tangent. to a circle and a circle. Common point to a circle and circle. This point is called point of contact. This point is called point of contact. Okay. How many tangents can a circle have? A circle have infinite many tangents. There are infinite many points on circle and each point of it has a unique tangent. A tangent to a circle intersect it in how many points? 1 point. A line intersecting the circle in 2 points is called secant. A circle can have 2 parallel tangents at the most. And the common point of tangent to a circle and circle is called point of contact. Now, question number 3, exercise 10.1. Question number 3. A tangent PQ up at a point P of circle of radius 5 cm meets a line through the center O at point Q. So that OQ is equal to 12 cm. Then find length PQ. A tangent PQ at point P of circle of radius 5 cm. Here tangent PQ at point of circle is P. Of radius 5 cm meets a line through the center O at a point Q. O at point Q. At point Q. So that OQ is equal to 12 cm. OQ is equal to 12 cm. Length, then find length PQ. Here we have find length PQ. OP is radius. What is OP? OP is radius. PQ at point P of circle of radius 5 cm. Here radius is equal to 5 cm. OP is radius equals to 5 cm and OP perpendicular PQ. In triangle OPQ, what types of right angle triangle? Because it is a perpendicular. Therefore, we use here Pythagoras theorem. By Pythagoras theorem, in triangle OPQ. What is Pythagoras theorem? Here, yes, OP square plus PQ square equals to OQ square. Yes, correct. OP square plus PQ square is equals to OQ square. Now put the value. OP square. What is value of OP? OP is equals to 5 plus PQ. We find. We want to find here PQ and OQ. What is the measure of OQ? OQ is equals to 12 square. 25 plus PQ square is equals to 144. PQ square is equals to 144 minus 25. Then PQ square is equals to 119. PQ is equals to under root 119 centimeter. Length of PQ is under root 119 centimeter. In textbook we have given option and therefore option is under root 119 centimeter. Suppose option is not given, calculate the sum, then find length of PQ, otherwise find PQ. Then we write this type of a tangent PQ at point P and Q of a circle of radius 5 cm meets a line through the center O at a point Q so that OQ is equal to 12 cm. Length PQ, find length PQ. OP perpendicular PQ by Pythagoras theorem. OP square plus PQ square is equal to OQ square. We find PQ is equal to under root 119 centimeter. Now question number 4. Draw a circle and two lines parallel to a given line such that one is a tangent and other is secant to the circle. Here draw a circle. Given line such it is a given line L. And two lines parallel to a given line. We want to draw two lines parallel to L such that PQ is a tangent. Here line, this is line AB. One is a tangent parallel to this. I called it as PQ, line PQ parallel to this line. It is called tangent. And other secant, which is secant. A line intersecting 2 points to the circle, it is called secant. Here A, B, PQ, then I take here 2 points. CD, it is called secant, which is parallel to given line. Parallel to given line. Parallel two lines parallel to a given line such that one is a tangent and one is a secant. Okay, we draw only this figure. Now exercise 10.1 is completed.